Okay, so let us now discuss question number 23 from the practice sheet. Last time we have discussed up to question number 21. 22 question you can do it yourself because it's easy. We have already discussed this question in some other question. Okay, so let us now discuss question number 23. Question number 23 says if AB, AC and PQ are tangents in figure and AB is equals to 5 centimeters, find the perimeter of triangle APQ. Okay, so there is a figure given in question number 23. The figure is very simple. There is a circle and on this circle there are three tangents. One is this one, another is this one, and another is this one. This three tangents are given to this circle, and this point is point A, this is point P, this is point X, this is Q, this is B, and this is C. So this is the figure given in the question. Now it says AB is equals to 5 centimeters. So AB is this length and AB is equals to 5 centimeters. You need to determine the perimeter of triangle APQ. So you need to determine perimeter of triangle APQ. This is APQ triangle. This is the APQ triangle. You need to determine its perimeter. So how to determine its perimeter? There might be some concept of circles that we need to apply to determine its area. But try to remember the last question that we have done. We have done in 21st question, we have proved a simple relation in that question. In that question you might remember that this AB was AQ. Okay, this B point was Q point in that question, in question number 21. And we have proved a relation that AQ is equals to half of perimeter of triangle. We have proved this relation already. So you know very well how to prove this relation. So in this question what you need to do is you need to prove this relation first, and using this relation you need to determine the perimeter of this triangle. What I am going to do is I am going to directly apply this relation to determine the perimeter. I am not going to solve the question number 21 again. You can solve it because we have already done it. So using this relation I can write perimeter of triangle APQ is equals to 2 times of AB. Why AB? Because you remember AQ is what? AQ is basically a tangent to the circle from an external point A, okay, and which touches the circle at point Q. But in this question that Q point is replaced with B point. Okay, the point of contact of the circle and the tangent is point B. That's why I have written perimeter of triangle APQ is equals to 2 times of AB. Now what is AB? AB is given as 5 centimeters. So I can write perimeter of triangle is equals to 2 into 5, that is equals to 10 centimeters. So this 10 centimeters will be your answer. So in this way you can solve question number 21. First you need to deduce this relation, and then using this relation you can determine this 10 centimeter. I skipped the proof of this relation because we have done it in 21st question. So in this way we have solved question number 23. It's a very simple question. It's just the application of a relation that we have studied previously. So after 23 let us discuss question number 24. Question number 24 says from a point P two tangents PA and PB are drawn to a circle with center O. So it says there is a circle and the center of the circle is point O, and it is given that PA and PB are two tangents drawn from a point P. So from this line we can very easily understand that point P lies outside the circle. Okay, so it says if OP is equals to diameter of the circle, show that triangle APB is equilateral triangle. Okay, so question number 24. Let us first try to draw the diagram for this question. It says that there is a circle. So this is a circle, okay, and the center of this circle is O. So O is the center of the circle. After this, what we have done, we have assumed a point P outside the circle, and point P is such that the point P, the distance of point P from the center of the circle is equal to the diameter of the circle. So if I say let radius of this circle is R, then what is the diameter of the circle? The diameter of the circle will be 2R. It's very simple. So I will say that this P point is at a distance of, this P point is at a distance of 2R from the center of the circle. This is what I can say. Okay. After this it says that we have drawn two tangents from this P point to the circle. So this is first tangent, let us say this is PA, and this is second tangent, let us say this is PB. So PA and PB are two tangents drawn from this P point, this PA and PB, and it says if OP is the diameter of the circle, so OP distance is equal to diameter of the circle, that is 2R, radius of the circle is R, that is what I have assumed. Okay, it says if this is true, this is P is at a distance of 2R, you need to prove that the triangle APB is equilateral. Okay, so what is an equilateral triangle? A triangle which has all three sides equal is known as an equilateral triangle. So we need to prove that triangle APB is an equilateral triangle. So what is the condition for equilateral triangle? So if I prove AB is equals to PA is equals to PB, if I prove this relation, can I say that this triangle will be an equilateral triangle? Yes, I can say if I prove this condition. Okay, or if I prove that angle APB is equals to angle PAB is equals to angle PBA is equals to 60 degrees. If somehow I prove that all these three angles formed are 60-degree angles, because an equilateral triangle contains three angles which are equal, that is 60, 60 and 60. So if I prove that all these three angles are 60 degree, I can say that this is an equilateral triangle. Or if I prove all three sides equal, then also I can say that this triangle is an equilateral triangle. It's very easy to say this. Okay, so let us try to prove. Okay, so what should be our approach? Our approach should be like, we need to prove this or this relation. Okay, try to understand this concept what I am saying. Somehow it sometimes happen to us that we write the question, we write the to prove condition, we write the given condition, but still we are not able to figure out how to solve this question, how to approach this question. So try to understand this line. Try to understand the to prove condition, which conditions, which relations it want to prove this condition. Okay, so we want this to any of these and it will be done. So let us try to reduce. The first thing that we can note is that two tangents are drawn from this P point, PA and PB. And if P is an external point and two tangents are drawn to a circle from this P point, I can say PA is equals to PB. Why? Because of theorem 2. By theorem 2, I can say PA is equals to PB. So we have this PA and PB. Now, in triangle PAB, try to observe, in triangle PAB you have this PA and PB equal, so PA is equals to PB, ये हमें given है, ये हमने deduce कर लिया that PA is equals to PB, so I can say that this PA equal to PB implies that angle PAB is equals to angle PBA. क्योंकि इस ट्राइंगल में ये वाला साइड और ये वाला साइड इक्वल है, सो आई कैन से इनके अपोजिट एंगल्स भी कैसे होंगे, इक्वल होंगे. एंड व्हाट इज द रीजन फॉर दिस पर्टिकुलर कंडीशन, दैट एंगल्स अपोजिट टू equal sides are equal. Angles opposite to equal sides are equal. This is the condition that you can deduce, okay, that you can use. So now we have these two angles equal. Let us first mark these two angles. So we have proved these two angles as equal. Now, if somehow I prove that this angle is also equal to this angle or equal to this angle, it's done. I can prove that this triangle is an equilateral triangle. So let us try to deduce this condition. Now, if I join this center with this point of contact A, if I join O and A, so what is OA? OA is equals to R. OA कितना है? R के बराबर है, that is radius. And you can see OA is perpendicular to PA. Why? Because of theorem 1. OA is perpendicular to PA because of theorem 1. Now, after this, if you observe triangle PAO, if you observe triangle PAO, triangle PAO is a right angled triangle at point A. Right angled at A. This is a right angled triangle, right angled at A. Okay. So this is what our triangle looks like. This point is P, this point is A, and this point is O. This is the condition that we have. Okay. Now, in this triangle, what is the length of PO? PO is basically 2R. And what is the length of AO? AO is basically R. You can see AO is basically R. Now, since it's a right angled triangle, I can apply concepts of trigonometry here. I can apply the ratios of trigonometry here very easily. So, if I try to deduce this angle, can I deduce this angle? Can I deduce the value of this angle, the measure of this angle? Yes. Why? Because with respect to this angle, if you observe this angle very carefully, you can see that this is the perpendicular for this angle and this is the hypotenuse. So, what is the trigonometric ratio that relates perpendicular and hypotenuse? I have one relation, that relation is sine theta, sine of angle theta. Let us say this is theta. So, sine theta says it is perpendicular upon hypotenuse. So, what is perpendicular in this case? OA is the perpendicular, OA, and what is hypotenuse? OP. So, sin theta is OA upon OP. Let us substitute the value of OA and OP. So sin theta is equals to OA upon OP, which is equals to R upon 2R, which is equals to 1 upon 2. So it implies sin theta, this is sin theta, this is 2R, length of this side is 2R, and this is the perpendicular. This is equals to 1 upon 2. So if sin theta is equals to 1 upon 2, what does this mean? If sine of any angle is equals to half, that is 1 upon 2, then try to remember the table that you have studied in trigonometry. According to table, if sin theta is equals to half, it implies theta is equals to 30 degrees. So I will say theta is equals to 30 degrees. It means theta is angle APO is equals to 30 degrees. Angle APO is equals to 30 degrees. It means this particular angle is 30 degrees. Now this angle is 30. What about this angle? We have initially proved in some question that this PO is the bisector of APB angle. PO is the bisector of angle APB. PO is bisector of angle APB. It implies angle APO is equals to angle BPO. Okay, bisector means it's a line which divides this particular angle in two equal parts. So this angle is 30, it means this angle is also 30 degrees. Okay, this angle is also 30, this angle is also 30. So what about this complete angle? This complete angle is equals to 60 degrees. So this implies angle APO is equals to angle BPO is equals to 30 degrees. It implies angle APB is equals to 60 degrees. Okay, APB is equals to 60 degrees. Now observe triangle APB. In triangle APB, sum of internal angles will be equal to 180 degree. This condition you know very well. So in triangle APB, I can write angle APB plus angle PAB plus angle PBA is equals to 180 degrees. What is angle APB? It is 60 degrees. Plus you have PAB equal to PBA. Okay, you have these two angles equal, this angle and this angle equal. So it implies if this angle is x, this angle is also x, which is equals to 180 degrees. It implies x is equals to 60 degrees. So now if x is equals to 60, it means this particular angle is also 60 degree and this particular angle is also 60 degrees. So what condition we have? We have angle APB equal to 60 degree, PAB equal to 60 degree and PBA equal to 60 degree. So if all the three angles of a triangle are equal to 60 degree, I can say that particular triangle is an equilateral triangle. Okay. So after this I can write it implies triangle APB is an equilateral triangle. It implies triangle APB is an equilateral triangle. Okay. So you can see that in this question we have applied all the concepts that we have studied previously. We have applied the concept that this PO is perpendicular angle bisector of this angle APB. We have applied theorem 1 also, we have applied theorem 2 also. Okay. So all the conditions we have applied in this question, So this question is an important one. You can see we have applied trigonometry as well. Okay, trigonometry, usage of trigonometry is also very important in this question. Otherwise, we can prove this question without trigonometry, but it will be very lengthy process. Okay, that's why we have used this concept. So in this way, you need to solve question number 24. You can note down this question and then we will continue.